Alright students, this is Mrs. Cole and we are here to review what we have learned about what formulas mean before we go into tackling how we balance equations. So first of all, there's a couple parts to a formula. The first part we're going to look at is the element symbols. So example, you might see carbon as a symbol, or you might see hydrogen. When combined together they look like this, CH4. This is the carbon. That's the hydrogen. But you have to be careful because lowercase letters mean something different than uppercase letters. So let's look at an example with some lowercases in it. Copper is Cu. You notice the second letter is lowercase. And chlorine is Cl. You notice the second letter is lowercase again. So when we see it in a formula, we know that this part is copper and not carbon and uranium. And we know that this part is chlorine. Now let's see what those subscripts mean. Subscripts are the little bitty numbers that are beside all the letters. The subscripts describe how many atoms of each element is in a molecule. And this is really important. These subscripts really tell us the difference between different types of substances. For example, we have methane. This is carbon, one carbon, and 4 hydrogens that are attached to it. If you look at ethene, this is really close. We have 4 hydrogens, but now we have 2 carbons. You see, here we had just 1, here we have 2. This is very different because of what you can do with ethene. Now, methane and ethene are both odorless, colorless gases, and they both burn. And we use both of them, we find both of them in natural gas. However, these 2 carbon atoms have a double bond between them, and that double bond is very important. It allows us to make polyethylene, and this is plastic. So if you've ever used, if you ever look at a plastic and it says LDPE, that's low density polyethylene. And what it is it's just these ethenes, and we break one part of this double bond, and then you have an extra bonding site on this one, and you have an extra bonding site on this one, and it allows us to form these huge chains. And this allows us to make plastic. You just take a bunch of these ethenes and you smash them together, which takes apart this bond, and it allows it to make these long, long chains of polymers. And I don't know about you, but the plastic that I keep my milk in is nothing like methane or ethene. And the only difference between these is the little subscripts, the little bitty numbers. Otherwise, all it is carbon and hydrogen, but these little subscripts, these little numbers, tell us the difference between them. Let's look at another one. Here's another example. We're going to look at water and hydrogen peroxide. So here's water, H2O. That's nice. We like to drink it. It's good for us. And here's hydrogen peroxide, H2O2. You notice the only difference is the subscript on the O. This is a 1, that's why it's not written. And this is a 2. So for every 2 hydrogens, there's 2 oxygens in hydrogen peroxide. In water, there's 2 hydrogens for every 1 oxygen. And why is that important? Well, you want to drink water. That's good for you. You don't want to drink hydrogen peroxide. That's what we pour on our cuts. The reason we pour it on our cuts is because it's actually toxic, and it kills the bacteria there. And it does this nice little bubbling thing because our cells don't want hydrogen peroxide in it. It's toxic. So our cells actually have an enzyme inside them that reacts with hydrogen peroxide to get rid of it. Because once you react with hydrogen peroxide, it's no longer hydrogen peroxide. That's called catalase. And if you cut yourself, you've damaged those cells, and all those cells release that catalase. And all of a sudden now have something that's going to react with hydrogen peroxide when you add it to it. So this is a big deal when you're balancing equations, because you cannot change the subscripts. You change the substance. For example, here's one that we've done a lot in class. Hydrogen plus oxygen becomes water. It is correct to put coefficients, these numbers out front. So now I have 2 molecules, each with 2 hydrogens, so there's 4 total hydrogens. I have 1 molecule with 2 oxygens each, so I have 2 total oxygens. And now I have 2 molecules of water, each with 2 hydrogens and 1 oxygen, so 2 times 2 gives me 4 hydrogens, and 2 times 1 gives me 2 oxygens, that's balanced. It would be incorrect to make this balanced by trying to put a 2 here, because now you see I have hydrogen plus oxygen equals hydrogen peroxide. First, doesn't happen. Secondly, this makes a toxic substance, which is very different from water. So, don't change the subscripts. Here's some sources for my pictures. Most of my pictures came from Wikipedia because it's a nice free open resource, and these were some of my other ones. Thank you.